Okay, let's solve this problem. So here we have three charges, uh, 2q, 4q, minus 3q, and we would like to now calculate the charge, the forces acting on the charge 2q and charge minus 3q. We know that q is equal to 1 nanocoulomb. So it's 10 to the minus 9 coulomb. So let's start by the first one is calculating the force exerted on charge 4q. So force exerted on 4q will be equal to the force exerted by the charge 2q on 4q plus, in vectorial form, plus the force exerted by charge minus 3q on charge 4q. Okay. So let's start by the first one, this one. So the force exerted by charge 2q on 4q is the charge exerted between this and this. So it will be a force that is going. This is the force 4q because both charges are positive, so they will repel each other. And the charge exerted by, and the force exerted by charge minus 3q on 4q, it will be this way. So this is a charge exerted by minus 3q on 4q, because both charges are of opposite sign, 4q and minus 3q, and consequently they will attract each other. So 4q will go to the right because it will be attracted by the charge minus 3q. Well, then we just simply apply the Coulomb's law, which is the force between two charges is equal to this k, or the magnitude, let's say the magnitude, q1, q2 over the distance squared, and then we take care of the directions, knowing that this is x-axis and this is the y-axis, and the x-axis will have I as a vector, unit vector. So the charge 2q exert a force that is equal to k. We know that q, so it is 2 times q times 4 times q divided by the distance between the two charges, and the distance is 3 centimeters, so 3 10 to the minus 2 squared. And as we can see, this force is going downward, which means this force is has a minus sign along the y-axis. So it will be equal to minus 8 k q squared over 3 10 to the minus 2 squared j, and we can easily calculate it as minus 80 10 to the minus 6 j, and of course it is in Newton. Okay, and the force exerted by the charge minus 3q 4q is equal to k 3q times 4q over the distance, and now the distance is in 4 centimeters, and it is along the x-axis to the right, which is positive, and you can easily see that it's equal to 12 k q squared over 4 10 to the minus 2 squared I, and it is 67.5 10 to the minus 6 I, and in Newton. So this is the total force, this one plus this one. So the total force is the sum of both of them. Okay. Now let's go to another example, the same, but calculate another. So now, what is the, so we are calculating the force exerted by charge 2q and 4q on minus 3q. So now we are considering this force, this charge, sorry. Again, the force exerted on minus 3q will be the vectorial sum of the force exerted by 4q minus 3q plus the force exerted on exerted by 2q on minus 3q. Let's first draw this force. The force between 4q and minus 3q, the force of 4q exerted by 4q on minus 3q, it is going this way because the two charges have opposite sign, so they will attract each other. So minus 3q will tend to move to the left. Okay, so the F 4q on minus 3q is equal to minus 12k q squared over 4 10 to the minus 2 squared I. So you can easily see that the force is going to the left. Okay, so this is the force. And then let's go to the force exerted by 2q minus 3q. And you can see that this force has two components because this force is, so this force will go this way. This is the force F 2q minus 3q, okay? And this force will have two components, one component on the y-axis and one component on the x-axis. And we would like to calculate those components. So I will say this force has, I will call it F2x plus F2y. Now let's calculate this angle, theta. Okay, this angle theta, tangent theta, is equal to 3/4, which means theta is equal to 36.87 degrees. Okay, and the distance between, so the magnitude of this force 2q on minus 3q, the magnitude is equal to the usual Coulomb's force, 6k q squared, because it's 2q times 3q, which is 6q squared, divided by the distance between both of them. And the distance is the square root of 3 10 to the minus 2 squared plus 4 10 to the minus 2 squared plus 4 10 to the minus 2 squared. Okay, so this is the magnitude, and the magnitude we can easily calculate it is equal to 6 10 to the minus 6 Newton. So this is F2q minus 3q. Now we can easily see that this force will be equal. So F2, if we do the projection, this force will be equal to F2Q, to the magnitude cosine pi minus theta I plus F2Q minus 3Q cosine pi over 2 minus theta J. This will give us minus F2Q minus 3Q cosine theta I plus F2Q minus 3Q sine theta J. Okay, so it cosine pi minus theta, cosine pi 2 minus theta. And this will give us a sign, a negative sign here. So at the end, we will get, because we know F2Q minus 3Q from this value, all what we can do, we have to do is to calculate cosine theta, and we have theta, and we obtain minus 17.28 10 to the minus 6 I plus 12.96 10 to the minus 6 J. So this is the force F2Q minus 3Q. Okay. And the total force that we calculated here, so the total force here, this one, it will be the sum of both of them. So if it will be the sum of both of them, and so the total force on minus 3Q is equal, you can easily calculate it, is equal to minus 484.78 10 to the minus 6 I plus 12.96 10 to the minus 6 J. Okay. In fact, here I forgot to give you the value of this force. So the value of this force is minus 67.5 10 to the minus 6 I, which you will use later. Okay, so this is the force exerted on the charge minus 3Q by the two charges, 2Q and 4Q.